Hey guys, it's Ate here. So today I'm going to be introducing a topic that's been trending on Twitter for a very long time now, which is zero knowledge proofs. So if you are somebody that's been on Twitter and seen the word ZK all around, this is the video for you to watch right now. So coming over to what ZK is, let's actually talk about what is it in a single line. A zero knowledge proof essentially is a prover telling a verifier that X is valid without actually revealing any sort of information about X. So let's actually talk about that with a use case or a problem statement. So present modern day scenario, if Vitalik kind of wanted to prove to a cop that he is in fact actually Vitalik, he would have to maybe give his license or his passport, which is not at all ideal, which will reveal a lot of sensitive information which he might not want to reveal. So this is the problem that ZK proofs solve overall. So it allows you to prove that a statement is actually true without revealing any sort of sensitive information. So TLDR is you won't need to hand over any sort of sensitive information anymore. Pretty cool, right? So now let's head over to two kinds of zero knowledge proofs, interactive and non-interactive proofs. Interactive proofs means that there are multiple rounds of communication between the prover and the verifier to come to a conclusion. Non-interactive proofs, on the other hand, only have a single round of communication, making it very efficient and arriving at a conclusion. So diving into non-interactive proofs, the prover would have to actually prove a statement to the verifier through a single response, which has a challenge and an answer, which then the verifier would deem if it's correct or false. So it's a single round that he would have to maybe say that, hey, I know that he's going to be there at that location, but I'm not going to give you any context about it. So a very good example of that would be Wall-E. Wall-E is a very fun but very difficult game where you essentially have to locate this character within an image, it is supposed to be very difficult. So how would you kind of show somebody that you actually know the location of Wall-E without actually revealing his location? So the way you would do that is you would essentially look at the photo, you would locate where Wall-E is, and then you would take a screenshot of that photo and put that on a cardboard image. And you would show this to the verifier. So notice that this is a single round of communication. The verifier is going to look at this image. He's going to be like, hey, here is the screenshot from the image. And he, without any sort of context, he's going to actually know that you, in fact, know that where Wall-E is. So what we have essentially done is through a single round of communication, we have proved that we actually know the location of Wall-E without actually giving away his location. Pretty cool, right? So yeah. So now coming over to two kinds of non-interactive proofs is we have snarks and we have starks. So we're going to be diving more into snarks now because it's what we use at Reclaim Protocol. So second, non-interactive argument of knowledge. So I'm going to break down word by word. So second means that the proofs are going to be short and easy to verify. Non-interactive is just us bringing back to the previous slide, which means that it is running on a single mode of communication between the prover and the verifier. Argument means that the proof is computationally sound. It's not a proof, it's an argument, which means that the attacker would necessarily need to have an infinite computing power to kind of maybe create a false proof. And knowledge, which essentially says that the prover needs to know the secret, which is the underlying thing of the entire knowledge proofs. So what it means that you would essentially need to know where Wall-E is before you prove where you know what Wall-E is. So yep. So this ZK snarks is the kind of zero knowledge proofs we use at Reclaim Protocol to prove any off-chain data. So if you're building an app where you need to prove that you have more than 5 stars on Uber, you would need to use snarks. If you need to prove that you are you're an influencer on LinkedIn or Twitter with more than 10,000 followers, you could use zero knowledge proofs to do that without revealing any sort of information. If you want to prove to somebody that you've actually liked their photo without revealing your account, you could use this to do that as well. So yeah, this is a brief introduction to zero knowledge proofs. If you guys found it very helpful, please drop a like and a comment on what you guys want to see next. And yep, we will be coming up with more bangers like this very soon. So stay tuned for that. Peace.